Hello, and welcome to one of the most anticipated sessions of the day. I hope you've been enjoying the rest of the sessions at NestGen, learning more about BV loss regulations, about air traffic management, about docking station deployments. And now, in the track that is BV loss tech enablers, we have the session called Defining the Future of Traffic Management with UTM Architectures. UTMs or uncrewed traffic management is a traffic management ecosystem for air traffic operations. In a world increasingly reliant on aircrafts and drones for a variety of applications, the need for sophisticated, scalable, and secure traffic management solutions have never been more crucial. Chris has over 20 years of experience in the airspace industry and 16 years of working with Analytical Graphics, an aerospace software company. He has had various roles at the company, from system engineer to account executive, with a focus on scheduling communication system. In 2014, Chris co-founded OneSky as a subsidiary of Analytical Graphics Incorporated to focus on UTM solutions. Chris manages business relationships for OneSky and is responsible for customer outreach and industry engagement. He works with various organizations such as GUTMA, ASTM, ICAO, AUSI, Small UAV Coalition, etc., to understand the state of the art in drone technology and to keep us updated on the revolutionary progress. Chris also has a bachelor's degree in airspace engineering from Virginia Tech. He's also a commercially rated multi-engine aircraft pilot. It's great to have you, Chris, and I'm very excited myself to learn about UTMs and how they're going to be so crucial as autonomous aircrafts and drones become more and more popular. Now, just before we jump in, a few housekeeping rules for our audience. You may use the Q&A section for your questions. So on the right side of your screen, you have the Q&A tab where you can put up all your questions. And at the end of the presentation, Chris would be happy to take those up. The session is being recorded and will be published on Flightbase TV and on social media platforms, so you can check it out. You can also visit OneSky System booth in the expo section later. Next, if you like something, if you found something insightful, please do not forget to share your learnings or your experiences on LinkedIn. Use the hashtag NestGen and tag Flightbase. Top 3 posts will receive a special hamper from NestGen. Then last but not the least, I would like to thank our sponsors for their unwavering support throughout this event. Title sponsor DJI Enterprise and gold sponsor Sunflower Labs. With this, I will hand it over to Chris. And
Ajit, thank you. I apologize in advance if there's some background noise. I'm in the airport. I'm flying back from Singapore, where I attended the Singapore Air Show this past week, which was excellent, and it was good to see some of the colleagues there. So thank you for joining. I put my email in the chat if you want to follow up with me afterwards. And today I want to talk about UTM architectures and how they're the future of traffic management. So we already talked about my background. I'm also a commercial pilot. I've been flying for about 29 years, and I think that's interesting to have that background in the UTM industry, because a lot of times the crewed aircraft and the unmanned aircraft sort of don't see themselves the same, and they're not going down the same path. But I think that we need to think about them in the same context and think about integrating these two types of aircraft into the same infrastructure. Next slide. So one of the things that's very different from the air traffic management industry is the amount of stakeholders that we see in the unmanned traffic side. So the stakeholders at low altitude are people like the local law enforcement, the communities that you don't want to fly over jails or schools or parks, military operations that might not be integrated. They're not using ADS-B, for example, helicopter rescue missions. There's a lot of low altitude obstructions, environmental data that's different, low level altitude weather. So all these things are different from air traffic management. And so we have to think a bit more cooperatively. And how do we integrate all these cooperative data providers into one system? And so that is what UTM is. Many people think UTM is something that you can buy. that is just one system, and it's not. It is it's just a system of data and participants and stakeholders, and the real focus is on standards. How do we all talk a common language? Because without standards, it makes this problem very, very challenging. But I think that is one of the hardest things, is how to adopt standards. Next slide. So there's a new term called XTM, which is Extensible Traffic Management, and extensibility is sort of a common theme here. How do we move beyond what is typically ATM is a certified system used by air traffic control. It's based on broadcast traffic information, so like ADS-B or radar transponders, and fairly closed. And we need to move into something that's a little bit more open, networked, maybe based on trust. So how do you verify the data that you have? And then multi-stakeholder. So how many different stakeholders can plug into an ATM system, and also multi-domain. So thinking from UTM to air taxi to ATM, which is high altitude air traffic management. So extensibility is key, and this XTM concept kind of defines that. And UTM is really the key to XTM. Next slide. So these are different domains that we think about in XTM. So UTM is low level, below 400 feet. It's based on cooperative tracking because we don't have tracking systems to see drones. So we need to share position information through a network. And we want to operate anywhere. So anywhere we don't have infrastructure everywhere, we have to operate with network systems to make that available. And it's generally outside of air traffic control. So they don't want to tell a small drone to turn left or right or land. They basically define airspace where you can't fly. So it's really more airspace management than it is traffic management. And as you move up, you move into UAM, that's more integrated, 1,000 to 3,000 feet. These aircraft might have ADS-B, they might have transponders and be integrated into the air traffic control. But they're operating between vertiports, and those vertiports may have corridors that connect them to enhance the traffic flow between them. So one of the keys in UAM that I think about is predictability, because the endurance of these vehicles is very low. We need to make sure that when they take off, they have a place to land and they're not being put in a holding pattern. And so corridors allow for that predictability. So UAM allows us to look at the integrated picture, but think more about traffic flow. And then there's ETM. So ETM is the high E above 60,000 feet. And what we're thinking about there is very long duration flights. So you have high altitude airships that could fly for months or years. And the flight plan doesn't really stop, right? It just keeps going. So we have to think about how do we keep modifying flight plans as these aircraft keep moving along. So those are the three different kind of domains that we're thinking about for UTM technology. And then above that is space traffic management, which I'm not really covering. So next slide. So we have some polls throughout the presentation, and the first one is I wanted to understand how should we integrate new advanced air mobility's vehicles into various airspace domains. So you can go through the poll.
Yeah,
we can
poll is live in the
the
poll
answers.
section on the right. So I would request everyone to just go to the poll section and answer this poll.
Gee, do we want to stay on the poll or move through the slides and then come back to the poll?
Yeah.
Okay. Next slide. So UTM basically overcomes some air traffic management shortfalls for advanced air mobility. And these are really in these, kind of four different areas. One is where we need to have operators provide their cooperative traffic management information because we don't have systems to track them at low altitude or in different domains, ETM at high altitude. Where we have high volume operations and we need predictability. So we have different deconfliction concepts in UTM, strategic deconfliction versus a tactical kind of deconfliction. Even in the UATM, we have things that are called like demand capacity based operations where we measure the amount of traffic going into a corridor so we don't push everything in at the same time. and cause problems. We rely on third-party data. So it's performance-driven. It's checked, it's monitored, and it's not always certified data. So it's not purchased or provided by the ANSP, which is important. And then lastly, I think security. So because these are network systems, there are advanced security capabilities that you can put on the data. First of all, we're operating, in HTTPS protocols. We can authenticate different users, and you only see what you need to. So instead of broadcast systems, we can control who sees the data and when they see the data. And you don't always see another traffic object if it's not a safety threat, right? So that's some security that's there that might be good for things like military operations. Next slide. So it's based on this UTM architecture. You've probably seen this slide before, but I want to make a point here that the UTM could be more centralized or federated, and centralized meaning the ANSP would control the back end of it, who can be on that network, or it could be provided by the industry, which is sort of how we're anticipating this being rolled out in the US. And we have a network of different stakeholders that are interacting on the UTM network on their own. I think this is a good point, that when stakeholders want to interact in UTM, all they need to do is adopt the ASTM standard. If you're a law enforcement and you want to reach in and get information on UAS traffic, if you use the ASTM standard, you can get into the network and understand that. If you're an operator, you can send in a flight plan or a flight track. And if you're military, you can pull those tracks out and know where they are, so you don't have a safety issue. So anybody that wants to operate in the UTM environment, if they just use the standard, it's very easy for them to be on the network, because it's not one system. It's a standards-based environment. Next slide. Second poll. So I'm wondering from you guys, should we rely on all aviators to share position information? This is an interesting topic, because in many places, the incumbent, the general aviation or the crewed aviators, don't always have transponders. They don't have the technology that the drones or automated aircraft have. And so it's easy for us to share information. We actually have to, because we have remote pilots and we need to know where the drones are. But with VFR rules and smaller aircraft, they don't always have transponders. And that's been the biggest issue in terms of us being able to fly at low altitude, is seeing those other aircraft. So if everybody were to share position information, it might make it easier for us to fly. Next slide.
Yep.
I have another poll. I guess this is, should airspace restrictions be managed by a single entity like air traffic control, or do other stakeholders at a local level need control as well? So when we're down at low level, the community becomes more important. Where drones are flying over parks, they become more of a security or a safety concern. And so it may be out of the scope of air traffic control. And I'm just wondering what people think about airspace management and how that should be done, in this future traffic management system. Next slide. So just to show a little bit about how cooperative tracking works, you have any C2 method really from the drone to the ground control system. So if you're using satellite, if you're using LTE, if you're using point-to-point, it doesn't matter to the UTM. Once you get your information at the ground control system over the telemetry link, that's when it is sent to the UTM. So we want to send in the intent, which is the flight plan or the region of flight, and then you register that intent in the network. And so that's what I'm showing in these boxes is, it's a box drawn around your flight plan. So you don't have to share the entire flight plan. You just share the region that you're operating. And if those two regions overlap, then you have to share more information. You should talk and say, well, do my flight plans intersect, right? And if they don't, then you don't have to share any information. You're safe. So the idea of privacy is built into the UTM. It allows you to share information only when needed, and it makes it much easier to deal with. So you're only sharing little bits of information to ensure everybody's flying safe. There's also the idea of airspace management, which is shared as a constraint. So many people can provide constraints to the UTM environment as well, and the drone traffic can avoid those constraints if they're tied into the UTM. So that's basically the simplified UTM kind of concept. Next slide. And here's some service examples. So we have system performance information down on the left. You could have things like weather or GPS navigational accuracy performance. You could have ADS-B performance or communication system performance. And those are all services that can be brought in through UTM and supplied to the different operators. You can have separation management. So that's a service that allows us to operate safely and keep us away from other drones. And then airspace awareness services. So all the different people that might supply airspace to the network. Next slide. All right, and then just to wrap it up, so why UTM? So it's not a single system, but a cooperative approach. So the idea of UTM is to enhance cooperation. Let's make sure that all stakeholder needs are met, and we do that using a single standard that everybody can adopt. So it enables more than just air traffic control stakeholders to control airspace. We have low-level community adoption. We're encouraging electronic conspicuity, which is that idea that everybody can participate in traffic management by supplying their own track position and their own flight intent. And so that's more of an idea that people need to agree upon than it is a technology issue. What UTM does is it allows it to be done at lower cost, so you don't have to buy a device. You can just register your intent through the internet for your flight. You can do it in advance, and then all drones would stay away from you. And then the last one is performance monitoring to enhance, the third-party data trust. So all the data that's in the UTM is monitored, and we make sure that it's safe to use for operations. That concludes the presentation. We can go back to the polls, I guess, if you want to look at that real quick, Jeet, or you can just go to the questions, however you want to address that.
Yeah, I think let's start with the polls. So I think the first one was, how should we integrate new AM vehicles into various airspace domains? And let's see what the audience has answered. So there are 9 votes for allow for flexibility and use an open network to share information like ADS-B and LT. And then there are 3 votes for let ATC handle it. They're experts at what they do. We don't need a new approach. And then there are 2 votes for ensure all operators can use a common capability like ADS-B in all domains.
Yeah, so I think it looks like most people think that there should be some flexibility, and the network allows us to do that. But they're, ATC are experts at what they do, and I think integrating some sort of flexibility into the ATC system is the right approach, probably.
All right. Thanks, Chris. Let's move on to the next poll. So should we rely on all aviators to share position information? So let's see what our audience has answered. So there are 6 votes for there needs to be a balance. Let's share information when needed for safety. Then there are other 30% votes are for everyone should be required to share tracked data at all times. And then the least amount of votes are for privacy is really important to me. I don't think anyone should be forced to share data.
Okay, so most people are thinking that conspicuity is good and that we should share information. And then most people think there should be a balance.
Yeah.
And I think we can reach that balance with UTM when we understand we can share information only when we need to. That also helps with the military when they don't have ADS-B and they don't always want to share information, so they can share it just when they need to for safety.
Right. Yeah, I think the next poll was, should airspace restrictions be managed by a single entity like ATC, or do other stakeholders at a local level like military or police need control as well? So let's see what audience has answered. So there are 63.6% votes for the second one, that is more than just ATC, and then there are 36% votes for ATC only.
I didn't hear the answer, but say it again.
Yeah, so there are 63.6% votes for more than just ATC.
More than just ATC.
The B option. Yeah.
Yeah.
Most of
I actually thought that would be higher than more than just ATC, but I think that maybe we're hearing that some people think ATC should be a sort of an authority over airspace regulation or restrictions. So if you're a military or if you're police, maybe using ATC as the authority to put that restriction in. So that might be something that they could do through the UTM, is to enable the constraint. Even if it's supplied by somebody else, it could be enabled by ATC. Oh, great. Okay, thanks for participating in the poll. That was really interesting. And we can move over to Q&A, I guess. I'll let you handle it, Cheat. Which ones you want to pull out if you
Yep,
want.
I'll just go to the Q&A section. If you still want to ask any questions for Chris, just put it up in the Q&A section. So Chris, let's start with this question. It says, with the drones increasing in the airspace and with many more to come, should governments develop a drone-centric flight control authority wherein they have a visual aid over which area is a drone being performing operations? So I think this is more around, as we spoke about, having a central ATC authority. Or yeah, Chris, you can.
But I think that the idea of low-level low-level air traffic management is really airspace management. So the idea is you're not actually controlling a drone. So when you say drone-centric flight control, I don't know that we control the flight, but we control where they should be and where they shouldn't be. And I think that comes to the last question: is who puts in the constraints for where drones should and shouldn't be? That could be controlled by air traffic control, but I think the information should come from multiple stakeholders that know more about that information. So like cities, they know about where sporting events are and what sporting event start times and end times are. They know that better than air traffic control. So why not let them send the information into the central authority? But if you want the authority to actually make the rule, to make the constraint, they could do that as well. I think the ASTM standard, though, gives a really great approach to making temporary flight restrictions, where the existing NOTAM system is really troubled in trying to do that. It's based on non-structured data, and ATM is structured, and ASTM is much more easy to use for a temporary flight restriction.
Right. I hope that answers your question. Then there's a question from Rasmus. Rasmus has asked, what's the largest challenge in the standardization of UTM use space today?
So I think there are a couple things. First of all is the infrastructure based on the country and what's been put in place. So if you're in the US, for example, you have a large infrastructure of ADS-B based on a tower system. We're also using 1090 and UAT frequencies for ADS-B. If you go to a place like Japan, you don't have much ADS-B at all. And then if you go to Canada, you have ADS-B based on satellite. So you have different concepts for how you get information. So that's challenging. But I think the real issue with standards is just adoption. So, coming to consensus is a hard thing. And we've been working in ASTM for a long time to help get consensus. But I don't think that we expect perfection. If you look at the world, we still have the metric system, right, as opposed to English system. And people walking on the left or the right side of the road. So it's hard to even standardize day-to-day functions. But what is troubling to me is when I go to a country and I see them make bespoke integrations between an operator and air traffic control. And if they would just use the ASTM standard, then that work doesn't need to be redone every time you have a new operator. So I guess if I had one point here today, it would be, for everyone, pay attention to what the standard is. It's very basic, and it allows everybody to communicate. And once you can do that, then I think we really are making a difference with low-level traffic management.
Right. On a similar lines, there was another question: if there are any technical challenges at the moment for UTM platforms.
Yeah, technical challenges. I think from the drone operator integration perspective, that's always a little of a challenge because everybody wants to use a different ground control system. Sometimes they use their own, but it's not a huge challenge. Usually we can integrate them into the UTM within a day or two. So there's that. I think maybe the other one is just getting the information we need beyond strategic deconfliction to address the tactical side. So if we had crewed aircraft flying into the low-level airspace, how do we see them? So electronic conspicuity is a huge issue, but that's more of a regulatory thing. Technically, it might be how do we include them, in the low-level picture. Do we have ADS-B portables that we build, or can we integrate LTE tracker devices into UTM? But we need to enforce that over regulation, or we need to just let them know that if they use these devices, if crewed aircraft use these devices at low altitude, then they will be seen and avoided by the drone.
Got it. There's a question David is asking, how should the approval process go? For instance, it can be time sensitive. Do you see this changing in the future?
I think the approval process that we're talking about is for a drone flight approval.
Yeah, yeah.
And, like in the US, they have the Lance system for flights using Part 107, but they're visual line of sight only. So they've done some work to automate that, and it really has been beneficial where you can get an automated approval to fly. And then they expand that based on how they get comfortable with people flying at night or flying, in certain areas. They have shielded operations now that are pretty easy to get approval for.
Right.
I know what we've done in our system is we have a rule-based approach to approval. So, and any air navigation service provider or civil aviation authority can set up the rules in advance, and then the flight goes through those rules and it says, yeah, you can, or no, you can't fly. So I think each country will be different, but if you have a generic set of rules and you have an automated rule-based approach, that might be a good way to set up the approach. But I do believe it should be automated.
There's a question. I think this will be the last question we take. I don't see any other questions. How are UTMs different from ADS-B sensors? They both work to help perform safer flight operations, right? Kindly suggest what's the best. I'm a drone enthusiast and therefore have less knowledge. So,
yeah, no, it's a really good question. So ADS-B, is based on GPS, and when we get information from a UTM, we're usually getting it from GPS on board the drone, right? So, and sometimes you have two. You have ADS-B on the drone, and you have a GPS tracker that's used for flying it in the autopilot. And there's been studies even of comparing the two and making sure that that they're both from the same accuracy. ADS-B is more of a broadcast system, where what we're doing in UTM is more of a network system. So the telemetry data that comes down from the drone is the operator's data. And I think that might be the main difference, is the operator knows where the drone is at all times, probably better than the ADS-B system, because that's based on something else having to receive the information versus the command and control system. But I think they work hand in hand, and I think that they can help validate each other. So I think the use of ADS-B and UTM is a really good approach.
got it. I think with this, we come to the end of the Q&A section. Chris, thanks a lot for the session. I personally found it quite informative. I hope the rest of the audience enjoyed this as well, learned about UTMs, also like new terms, AMs, XTMs, all of these things. And there are a few more sessions left for tonight before we wrap up NestGen. So I would, I would really hope you are enjoying all the sessions, and you will also find the rest of the sessions quite insightful. We have a few panel discussions coming up as well. Also, if you really enjoyed the NestGen experience, you should also check out NestGen community, which we have launched today. So along with experts and all the people in the industry, there would be a community of people who are progressing towards this one goal, which is to really have this level of drone autonomy where everything is well integrated and safe for flights. So I would really recommend all of you to navigate to the chat section and click on the link for the community. And yeah, thanks a lot everyone for tuning in today.
Thanks for hosting, Jeet. I appreciate it.
Thanks, Chris. Have a great day. Bye.